Hey everyone, welcome back to my YouTube channel. I hope all of you are doing really well. Today we are going to learn about bitwise operations, which is really important topic when we deal with microcontrollers or any project in general which deals with hardware level drivers or memory access. So without any further ado, let's get started. So first let me quickly show you what all things we will learn and in what order we will learn them. So very first thing that we will try to understand is the basic difference between decimal and binary number system. Then we will see how logical operators like AND, OR and XOR works with binary numbers. And then we'll see how does bit shifting works, and finally we will see some practical applications of bitwise operations in our microcontroller projects. So let's talk about the difference between binary and decimal number system. So decimal number system have base 10 and binary number system have base 2. So let's understand what does this base exactly means. So we will consider one random decimal number. Let's say we consider 576 as a random decimal number. So this 576 can be written as 500 plus 70 plus 6, which can be further written as 5 into 100 plus 7 into 10 plus 6 into 1, which further can be written as 5 into 10 raised to 2, as 10 raised to 2 is 100, and 7 into 10 raised to 1, as 10 raised to 1 is 10, plus 6 into 10 raised to 0, as any number raised to 0 is 1. So now we can see one pattern that every digit in our decimal number is multiplied with 10 raised to n, as 5 is multiplied with 10 raised to 2, 7 is multiplied with 10 raised to 1, and 6 is multiplied with 10 raised to 0. And in this particular 10 raised to n, the value of n will depend on the position of particular digit. For example, our 6 is at 0th position, so 10 raised to 0. 7 is at first position, so 10 raised to 1, and 5 is at second position, so 10 raised to 2. So I guess now we have understood how decimal number system works and how base 10 comes into picture. And digits present in any decimal number are always between 0 to 9. Now we will see concept of binary number. So in any binary number, each digit or bit can take only two values, that is either 0 or 1. And hence it is called as a binary number system. Let's consider one binary number. So here we have considered one binary number, that is 11011. So as we multiplied each digit of our decimal number with 10 raised to n, and n value was dependent on the position of that particular digit. Similarly, here we will multiply each bit of the binary number with 2 raised to n, as 2 is the base for binary number system. So our number will be written as 1 into 2 raised to 4, because this particular 1 is at 4th position if we consider this first bit as 0th position. So this will be at 0th position, this will be at first position, then this will be at second position, this will be at third position, and this one will be at fourth position. So we have multiplied this particular 1 with 2 raised to 4, and then we are adding it with 1 into 2 raised to 3, and similarly 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. So this can be further written as 16, as 2 raised to 4 is 16, plus 8, as 2 raised to 3 is 8, plus 0, plus 1 into 2 raised to 1, that is 2, plus 1 into 2 raised to 0, which will be 1, as any number raised to 0 is 1. So it comes out to be 27, which is decimal number. So now we have understood what is the basic difference between decimal number system and binary number system, and how you can convert your binary number into your decimal number. Now let's understand operation of logical operators like OR, AND and XOR. So we will start with OR operator. So let's consider this very simple example where there are two inputs A and B, and output is denoted here. So if there are 2 bits, so there are like 4 combination of arranging those bits. Either those 2 bits are 0 if first bit is 0 and second bit is 1, first bit is 1 and second bit is 0, or both bits are 1. So OR operator will return output as 1 in all cases except when both the inputs are 0. So here both the inputs are 0 only in this first case, so output will be 0 over here, and in rest of the cases output will be 1. So this is how OR operator works. Now let's move on to AND operator, and here also we'll consider a similar example. A, B are 2 bits and this is output, and again there are 4 combinations 0 0 0 1 and 1 0 and 1 1. So here we are basically dealing with AND operator. So AND operator will return output as 1 only when both of the inputs are 1, and in rest of the cases it will return 0. So here both the inputs are 1 only in one case, that is the last case, so here it will return 1, and in all other cases it will return 0. So this is how AND operator works. Now let's look at XOR operator. So again same truth table, A, B and output. Again 4 combination of bits 0 0 0 1 1 0 and 1 1. So XOR will return 1 when both the inputs are different, and it will return 0 when both inputs are same. So in the first case, as both inputs are 0, so both inputs are same, so it will return 0. Here A is 0 and B is 1, so both inputs are different, so it will return 1. And here A is 1 and B is 0, so both inputs are different, so again it will return 1. And here as both inputs are 1, so it will return 0. So this is how logical operators OR, AND and XOR works with binary numbers. So as now we have understood basic working of AND, OR and XOR operators, let's perform these operations on 2 binary numbers. So let's consider 2 binary numbers 10110 and another one as 11001. So let's first perform OR operation between these 2 numbers. So we will write first number, then we will write second number right below it. So for OR operation or for any logical operation, the bits which are present on the same position will be considered while carrying out that particular operation. So for example, 0th bit will be ORed with 0th bit only in both the numbers. So this 0 will be ORed with this 1, this 1 will be ORed with this 0, this 1 will be ORed with this 0, this 0 will be ORed with this 1, and this 1 will be ORed with this 1. So let's see what is the result of OR operation. So 0 and 1 will return 1, 1 and 0 will return 1, 1 and 0 will return 1, 0 and 1 will return 1, 1 and 1 will return 1. So this is the result of the OR operation between these 2 numbers. Now let's do AND operation. So this 0 and 1 will return 0, this 1 and 0 will return 0, this 1 and 0 will return 0, this 0 and 1 will return 0, and this 1 and 1 will return 1. So this is the result of AND operation between these 2 numbers. Now let's see what is the result of XOR operation. So let's write first number 10110 and 11001. So this 0 and 1 will return 1, this 1 and 0 will return 1, this 1 and 0 will return 1, this 0 and 1 will return 1. So as we saw in our previous explanation that XOR of same input will result into 0. So XOR of this 1 and 1 will result into 0. So this is the result of XOR operation between these 2 numbers. Now let's try to understand how bit shifting works. So there are 2 types of bit shifting operations. One is left bit shifting and another one is right bit shifting. Left bit shifting is denoted as this symbol and right bit shifting is denoted as this symbol. So this is left bit shifting and this is right bit shifting. So left bit shifting any binary number by 1 bit means shifting all bits of that particular binary number to the left side by 1 bit. So let's understand this particular thing with one example. So let's consider one binary number 101011. And now let's left shift this particular binary number by 1 bit. So what happens in left shift is all our bit will be shifted to left side by 1 bit. So this particular 0 will be shifted here, this 1 will be shifted here, this 0 will be shifted here, this 1 will be shifted here, and this 1 will be shifted here. And because this 1 will be shifted here, so this place will be vacant, so it will be replaced by 0. So this will result into as this 0 was shifted here, so answer will be 0, and this 1 was shifted here, so again 1, and then this 0 was shifted here, so 0, and then this 1 was shifted here, so 1, and then this 1 was shifted here, so 1, and because this place was vacant, so it was replaced by 0. So this is the answer when we left shift this particular number by 1 bit. Similarly, in right bit shifting, we shift all bits to the right hand side by particular number of bits. So in programming, bit shifting is expressed as follows. Left bit shifting is expressed as this expression, and right bit shifting is expressed as this expression. So this means that this x number is left shifted by y bits, and this means that this x number is right shifted by y bits. So this is how bit shifting works, and again it is really important concept and very frequently used in bit manipulation. Now let's see some practical implementation of whatever we have learned. So in microcontroller there are a lot of registers which are used for configuring that particular microcontroller, and registers are nothing but bytes in memory. So if we want to do some configuration, we need to modify values of these bytes. So let's consider there is some 8-bit register A in any particular microcontroller, and which has a value of 10111011, and suppose we want to modify this third bit over here, and we want to modify this particular bit to 1 because right now it has the value of 0. So we can do this thing with help of OR operation. So with help of OR operation, we will be able to modify this value of this particular bit without changing the value of rest of the bits. So how we can do is we will have to perform an OR operation between this byte and following byte. So we will take rest all the bits as 0, and whatever bit we want to change, we will take that particular bit as 1. So now when we will perform OR operation between these two numbers, we will get 1 over here, and like rest of the bits which are present here and here will be having same values. They will retain the same value because they are odd with 0. So for example, this 1 odd with 0 will give us value of 1 only. 0 odd with 0 will give us value of 0. 1 odd with 0 will give us value of 1. Similarly, all other bits also will retain the same value. So this is how we can write or modify any particular bit in any particular register in any microcontroller. So now instead of modifying this particular bit, now we want to read value of this particular bit. So for that we will have to do AND operation of this particular number with following number. So what we'll do is we will keep this particular bit as 1, and we will keep rest of the bits as 0. So now when we do AND operation between these two numbers, we will get value of rest of the bits as 0 because we are doing AND operation with 0 for rest of the bits, and for this particular bit we will get value of this bit because we are doing AND operation with 1. So this is how we can read value of any particular bit in any register. So now you might have understood that how important role AND and OR operations play in reading and writing bits. Similarly, bit shifting also has a lot of practical applications. One such application is calculating number of ones present in any binary number, which is also called as parity calculation. So instead of directly sharing a solution for this particular problem, I would like you to think a bit and find solution for it. If you manage to find solution, then please post it in comment section, because finding solution by yourself will improve your understanding. with respect to bitwise operations. So now it's time to end the video, and if you found this particular video useful, then please like and share this video, and also subscribe to the channel if you haven't subscribed yet. Thank you for watching the video. Bye and take care.